the atomic, if we look back at our periodic table, we'll discover that element E is element number 13 on the periodic table, and that position gives us the atomic number of the element. So the atomic number of E is 13. And what does it mean for an element to have atomic number 13? We go back to our notes which we were given. For an element to have atomic number 13, it simply means the number of protons in the nucleus of that atom is 13. So this statement already answers our question for the number of protons that we are looking for. That is 13. Since the number of protons in the nucleus of an atom gives the atomic number of that atom. So the number of protons is 13. So the Roman 2, that says the number of electrons. So we have to get the number of electrons. Now, in a neutral atom, we should take note that in a neutral atom, the number of protons is the same as the number of electrons. So what are we saying? Since there are 13 protons, it simply means there are also 13 electrons. So number of electrons is 13. The Roman 3, the number of neutrons. So we were given a ratio that we usually use to calculate the number of neutrons, and that ratio is given as number of neutrons denoted by capital N is equal to the mass number minus the atomic number. So this is the ratio that we were given. So this is the formula that we were given that helps us calculate the number of neutrons. So if we apply that in this case, our mass number was given as 27 minus the atomic number which we already determined as 13, and this gives us an answer of 14 neutrons. So there are 14 neutrons present in the atom E. Question 1D. Question 1D. Number 1. D says two elements X and Y have atomic numbers 6 and 17 respectively. Element X and element Y, they have atomic numbers. Z for X is 6 and Z for Y is 17. Now Roman 1 says write the formula of the compound formed between X and Y. So we have to write the compound that is formed between X and Y. Compounds are formed with the notion of valency. Now what is a valency? A valency is simply the combining power of an atom. That is what this valency means. So we first of all have to start by looking for the valency of X, and we look for the valency of Y. That cannot be gotten without their electronic configurations. So we start by stating the electronic configuration of element X. From their atomic numbers that were given, the electronic configuration of element X will be 2, 4, and that of y will be 2, 8, 7. So now, the number of valence shell on the outermost shell will give us the valency of that atom. So the valency for X is 4. Now for the case of Y, we notice that Y needs 1 electron to attain the most stable state, because for you to be stable as an atom, you need a maximum of 8 electrons on the outermost shell. We cannot say we are taking 7 because of the reason that you need just 1 electron. Y needs just 1 electron on the outermost shell for it to be stable. So we are using the notion that we were told that to get the valency, once the number is already greater than 4, the number of valence electron on the outermost shell, once it's already greater than 4, we use the sum total of the number of electrons that will make that element to be complete, which is 8, and we subtract the actual number of electrons that are present on that element, which is 7, and this will give us an answer of 1. So this 1 here is the valency of Y. So our valency in this case for Y is 1. Now back to our compound. The ratio of the compound formed between X and Y. We said the valency of X is 4 and that of Y is 1. So we cross multiply, we'll have X, Y, 4. This implies we'll end up with the element XY 4. So thanks to the valencies, we discover that we come out with a compound XY4. The Roman 2 part. Roman 2 says, identify the bond type in the compound in Z Roman 1 above. Identify the bond type. Now, talking about bonds, we have to know that there are 2 types of bonds. That is, the first one is ionic bond, and the second, you have a covalent bond. Now we will take each of the cases and we see what happens. Now for an ionic bond, what happens during an ionic bond is that you either find a group 1 metal transferring electrons to a group 7 non-metal. So you have a group 1 metal that transfers electrons to a group 7 non-metal. This is the first case, and the second case, you find a group 2 metal transferring electrons to a group 6 non-metal. So the summary for ionic bond is that you either find a group 1 metal transferring electrons to a group 7 non-metal, or a group 2 metal transferring electrons to a group 6 non-metal. So in this case, there is transfer of electrons. Whereas when we look now at the covalent part of it, for covalent bonds, the first thing we have to know is that there are two types of covalent bonds. The first, you have an ordinary covalent bond, and the second is a dative covalent bond. Now, what happens during an ordinary covalent bond? First of all, during covalent bonding, we must first of all know that there is what we call sharing of electrons. Now, for an ordinary covalent bond, there is sharing. Now, in the sharing of these electrons, each participating atom brings in electrons that are meant to be shared. So there is sharing, but there is participation by both elements. So both elements bring electrons for sharing. Whereas in a dative covalent bond, just one of the participating atoms bring in the shared pair of electrons. So ordinary, both participate in the sharing of the electrons, whereas for dative